Hello, and thank you for joining me today. I'm Russ Savage, and I'm a product manager here at Influx Data. I'm really excited to be here today. I'm going to walk through some of the main requirements we see for game developers as they try to gain observability into their technology stacks. Next, I'll introduce you to the InfluxDB cloud platform and give you an overview of the tools and capabilities available to you as you work through customizing the monitoring framework for your next big release. And finally, I'll talk through a few customer examples of how they're using InfluxDB to support their business cases. But first, let's start with something obvious. Game launches, they aren't easy. I'm sure many of you are all too familiar with these types of headlines, and these are just a few I found with just a quick Google search. It seems like launch day problems are sort of the norm for any game with a decent level of hype today. Of course, these are a little bit of a nice problem to have, but as a developer and also a player of games, it's incredibly frustrating to see something you've worked on so hard or waited so long for get eaten alive on launch day. I'll be totally honest with you, I'm not that familiar with the intricacies of building gaming backend services, so I'm not going to stand here and lecture you about proper video game architecture or designs, but I am familiar with the intricacies of running large-scale infrastructure for software APIs and services. We run massive Kubernetes clusters across multiple public clouds for our InfluxDB platform. These configurations are very different than some of the configurations you might be used to, but there's a ton of similarities when it comes to monitoring. So here's a reference architecture I pulled from some AWS documentation about game design. Now, of course, like any reference architecture, probably doesn't look anything like the backends that you've worked on, but architecture accuracy isn't really the point here. The point is that this is probably the cleanest possible configuration of services you could ever have to accomplish what modern games need to accomplish. And it can still barely fit on a slide. I count 12 different services interacting here, which doesn't even factor in all the internal services and custom services your game might rely on. So, when everyone says, well, why didn't they just add more servers? Server capacity is only one part of a complex backend system that's really needed for games today. So this brings us to our first requirement for gaining observability into your backend gaming stack. And it's that game developers simply need to monitor more services than ever before. What we've seen over the past few years as companies fully embrace the cloud, they're moving from physical machines to virtual machines to containers inside those virtual machines. Each of these levels multiplies the amount of metrics that you need to keep track of because the life cycles change. Servers don't usually reboot regularly, but because containers and virtual machines are auto-scaled by orchestrators as loads change, they can come and go frequently. Orchestration planes like Kubernetes are constantly scaling and rebalancing pods based on the needs of the business, and they're extremely powerful, but they come with a need for additional monitoring to ensure the services and everything is happening correctly. Services have also exploded, and users need to monitor not only the latest services built by their engineering team, but usually some legacy systems that haven't really been touched in years, and all the networks and infrastructure to connect everything together. Of course, to meet the demands of this market and this need, tons of bespoke solutions have been developed, but it takes time to learn new systems. It's hard to stitch it all together. How do I see all my metrics together in the same tool? How do I keep my data from getting siloed into custom platforms or tools that my team has to learn and connect to? When seconds count and there's an outage, having to fumble around to get access to learn a new tool, it only slows teams down. It's a huge problem. The amount of data and tooling, it's only going to continue to increase in the future. The second issue we see today is that there's really no testing substitute for going live to your users. This quote is from a former QA analyst at EA. From his perspective, all the beta testing in the world isn't going to replicate everything that could go wrong when you open up your game to the world. Now, obviously, you try to prep for everything, but if you sit back and you take the stance that there will be problems when the game rolls out, you can start thinking about how do I reduce my reaction time to those problems for a team that's finding and fixing issues. And that's really what this one is about, is how can I ensure that I react quickly when the inevitable issue shows up? Assuming I have more metrics than ever before coming into my backend services, how do I get quickly alerted and take action when something goes wrong? Of course, you also need to hope that it can be fixed without issuing a patch to the game. It can be fixed server side, but that's another story. So players are always online, meaning the amount of downtime directly impacts the user experience and the company's bottom line. It's a little different than, a website going down where, if they hit refresh a few times, then the page comes back. When you get disconnected from the middle of your game, you tend to notice that a lot more. Finally, to round out the top requirements, infrastructure budgets for new games, they're already pretty lean and they're not increasing. Budgets they aren't increasing in line with expectations for the monitoring infrastructure, which means you constantly have to ask how to do more with less. Anytime you need to scale or solve a new problem, you want tooling that you can build on to support your changing requirements. When I look at this, I usually think of this as I never want to hit the edge of my tooling. So as a developer, I've got a sense of, kind of the code and what it looks like behind the scenes. And so when I see something that should work that doesn't, or something just beyond the reach of the tool that I'm using, it's extremely frustrating. And so you're looking for tools that can expand as your use cases and your operations expand. So let's recap. What are the top requirements for a monitoring observability platform designed for gaming infrastructure? We need the performance to collect and analyze data from any source, software, hardware, state-of-the-art, or legacy. We need to react to issues as fast as possible, filter the signal from the noise so that we can try to find problems as fast as possible. And we need to manage cost by doing more with less. So, of course, with that in mind, I want to introduce you to our InfluxDB cloud platform and walk you through some of the capabilities that might help you solve these problems. So here's just a screenshot of one of our straightforward monitoring dashboards, just to give you a sense of the look and feel. But InfluxDB Cloud, it's a platform built around these three pillars: accumulating data from any source, analyzing and processing that data in real time, and then acting on that data to resolve issues quickly, all while only paying for what you use and not a penny more. So our core focus is really on developers and builders creating the next generation of time series applications. And whether that's tooling around monitoring their own infrastructure or custom monitoring applications to support their business, we just want to support those developers and builders. And when I talk about a platform, it's a little hard to make it concrete in your mind. So here's a kind of a high level diagram of how these tools fit together. So I'm going to start from left to right. We'll start with Telegraph, the most powerful open source data collection agent out there. I always say if a metric exists, it can be extracted using Telegraph. It's a tool. It's got over 200 plugins for collecting data from anywhere, and it can quickly be extended to include custom plugins written in any language or any platform. So there's really nothing else out there. And I love it. I use it every day. It's extremely powerful. Of course, not all data is meant to be collected by a data collection agent. So we've got a set of powerful client libraries and native integrations to bring your data in. And all of the data ingestion happens via HTTP APIs. It's available as well. We really don't want you to worry much about getting your data into the platform. If it's metric or event data, we can ingest it quickly and easily. End of story. From there, data flows in the core of our platform, which is the InfluxDB time series database. We've been living and breathing time series data for nearly a decade, and our database is designed to ingest quickly and query in real time. Of course, the database is only one part of the platform. So to go along with the database, we provide a full set of developer tooling to make it easier to work with. This includes browser-based UI to make it easy to query, analyze, build dashboards, alert on your data. But it's also scriptable command line interface, as well as integrations into popular IDEs so you can write your code faster. Data processing can be done either ad hoc, in the browser, in your custom application, during your exploration or triage. It can also be scheduled and performed in the background automatically. So the data is always ready when you need it. So background processing can happen in the platform. The same background processing engine powers our alerting system, which means you get the full power and amazing flexibility when building alerting that you do when doing deep analysis on your data. So all that processing is done via a powerful query language called Flux. It's open source functional scripting language, and it has a powerful set of processing capabilities that continue to grow with every release. So it's designed for time series analysis. It can pull data from any source. It's open source and MIT licensed, and it's easy to get started and it's powerful to scale. So a few other capabilities that are really powerful I just wanted to touch on quickly before we move on. So InfluxDB templates, they're a great way to monitor common technologies out there with a click of a button. Templates include pre-built dashboards and alerting, and they're built by the community of developers who are familiar with that technology. And that means that even if you don't know all the metrics that you should be looking at when you're looking at a particular technology stack, you can still start monitoring that system with just a single click using the InfluxDB template. We also have a fully documented and unified API, which means you can develop against APIs locally or in the cloud, doesn't matter. And all you have to do is change your connection details when you want to move between the two. So in summary, we have everything you need to ingest, analyze, and act on high volumes of data real time for your business. So let's look at what some of our customers are doing with this technology. Electronic Arts is one of the largest gaming studios out there, and they chose InfluxDB to build a custom monitoring solution for their company. It helps them improve visibility of metrics across the organization and enhance their customer experience by combining metrics from various tools quickly and easily. Next, we have Disney Plus, and while they aren't really a gaming platform, they have a ton of peaky scale concerns as new content is released. So we figured they'd be a good example. They chose InfluxDB to improve their quality of service metrics and ensure their service uptime by collecting all of their infrastructure and application metrics in a single place. And finally, and this is definitely not a gaming company, but one that we love to talk about, it's Lego. So Lego uses InfluxDB as an industrial IoT hub, bringing data from all their factories in and improving the efficiency of their R&D process. So again, not really the DevOps use case that I've been talking about here, but a really cool example of just how flexible the InfluxDB platform is. So these examples of how companies are using InfluxDB platform improve their uptime, they keep everything running smoothly, and we love our customers. So let's recap. You needed something that could ingest large amounts of data from anywhere, react in real time, triaging issues, and not have any wasted cost. We think InfluxDB Cloud hits those marks for all the reasons that we've been talking about. Thank you for listening today. And if you want to get started for free, the InfluxDB Cloud platform, just visit us at influxdata.com/cloud. We'd love to hear what you think. Thank you very much.